This is our second lesson on the cosine law. It's part 2. Last lesson we talked about the actual cosine law, and it's kind of reminiscent of Pythagorean theorem at the beginning, but because we're not working with the long hypotenuse side, we're actually reducing it by 2 times the AB times the cos of angle C. Now we also remember that whatever side length you have here, the angle at the end, the cosine of that angle, has to be across from the side length. And then the two in the middle, the A and the B, are your two other sides, and your A and your B also go here. So for this particular example, we're going to determine the indicated value. We want to solve for side A. So side A is across from angle A. That means when I set up my cosine law, I'm going to put A by itself, so that I can do the cosine of A on the other side. And we're going to have B squared plus C squared minus 2BC times the cosine of angle A. And then we'll fill in what we know. We don't know A, but we do know little b's across from angle B, so that's 115 squared plus 95 squared minus 2 times 115 times 95 times the cosine of 110 degrees. And then remember, we're going to put this in our calculator in one foul swoop. 115 squared plus 95 squared minus 2 times 115 times 95 times 110 cosine equals. And I get a really big number here. I get 29,723.14 roughly. And then to get A by itself, we're going to square root that, and that gives me 172.4 roughly kilometers, or about 172 kilometers if we round to the nearest kilometer. Now that should make sense. Your largest side is always across from your largest angle, and since we've got 110 degrees as our angle A, then side A is going to be the longest because the angles have to add up to 180 in the triangle. So that means angle B and angle C will be smaller than 110 degrees. All right, part B here, we're going to solve for angle D. Now, this is different than what we've been doing. We're going to actually solve for the angle. That means, in this case, we cannot use sine law. We can't use SOHCAHTOA. Sine law, we would have to have an angle and a side across from it, and we don't have any angles at all. So cosine law fits in here, and since it's angle D that we want to find, I want to make sure that my sine law has the cosine of angle D in it, which then means when I set it up, I'm going to put side D squared here. I'm going to have my E squared and my F squared. So I chose to put D squared first because I want to solve for angle E, which means in my equation, then I can put the cosine of angle D. And if I said E by accident, I meant angle D. I'm solving for angle D. So put inside E, which is across from angle E, which will be 19.5 squared plus F is the 24.8 squared minus, I'm going to run out of room here. The other thing I also am putting in this time, which is different, is I actually have side D. So I'm going to put in the 15.7 where we have that D and square that. And then we're going to have minus 2 times 19.5 times, I'm just going to continue it down here, times side F, which is 24.8, times the cosine of angle D. Now, these are tricky to solve. These are much, much more tricky to solve. So let me show you what we're going to do here. We want to get the cosine of D eventually by itself, but currently it has all of this other stuff attached to it through multiplication. So the way we're going to end up undoing the minus 2 times 19.5 times the 24.8 will eventually be by dividing it away from the cosine. But before we can do that, we're going to get rid of the 19.5 squared because we're going to undo adding and subtracting first. And we're going to undo the 24.8 squared from both sides. So we have to subtract it from both sides here. So I'm actually going to rewrite this because this looks really crappy It's all over, mumble jumbled all over the place here. So let me fix that up. We still have our 15.7 on the left side of the equal sign, and that is being squared. We're going to take away the 19.5 squared, and we're going to take away the 24.8 squared. And that's going to equal the product of 2 times 19.5 times 24.8, which is 967.2, and that's what's multiplying the cosine of D. So if you're wondering where that magical negative 967.2 came from, it came from actually multiplying the stuff I've underlined in green. That's where that comes from, and it's multiplying the cosine of D. The other piece, we have undone these things. We wanted to get rid of them. So we've taken them away from both sides of the equation. So hopefully that's making sense there. Now, I'm going to actually calculate that left side with my calculator. 15.7 squared. I'm going to subtract 19.5 squared and subtract 24.8 squared. And I get negative 748. Negative 748.8, and that's equal to negative 967.2 times the cosine of angle D. Then to get angle D by itself, the first thing I'm going to undo at this point would be by dividing, I'm going to undo that 967.2, that negative, which is multiplying, by dividing both sides by that. I'm trying to spit out my words here and it's not working all that well. All right, so divide that answer in my calculator by the negative 967.2, and I get approximately 0.7742. I'm just rounding it to 4 decimal places, and that's equal to the cosine of angle D. And now we know to get D by itself, we're going to do the inverse function of cosine. So cosine to the negative 1, inverse function, or the shift button of cosine, to get angle D by itself there. So shift cosine on my calculator. Shift cosine, that gave me about 39 degrees there, just to the nearest degree. So D is equal to about 39 degrees. Now if I look at my side lengths, 39 is small, 39 degrees, and it's across from the smallest side. So I'm thinking my answer seems reasonable there. All right, moving along here. Jerry has a triangular backyard with these side lengths, and a bag of fertilizer covers 400 square meters. How many bags of fertilizer will he need? Well, this is talking about area, so I'm going to need the area of the triangle. But first, let's set up a picture of the triangle so we can work with that. So I've got one side that's 21 meters, a long side of 27, and one of 18. So I'm going to make my shortest side be the 18 meters just so it doesn't look too crazy. My second longest side will be my 21 meters, and I'll make my longest side be my 27. Diagram obviously not to scale. Now I know area for a triangle. The area of a triangle is the base times the height divided by 2. The height always has to meet the base at a 90-degree angle. So I know my base in this case, the way I've drawn my triangle, it's 27. I don't know the height yet, but we can get there. Notice I have a right angle triangle inside of my big triangle. I'm going to label this ABC, and I'm going to call this D in the center where that height meets the base. So triangle ADB is a right angle triangle. Triangle ADC is also a right angle triangle. But I only know one of those sides of either of those triangles, and I don't have any angles other than the 90-degree angle. So here's what I'm going to do. I'm going to use my cosine law, and I'm going to solve for one of my angles. Let's say I'm going to solve for angle C in here. I'm going to set this up so I have C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. And then I'm going to fill in what I know. I know side C is across from angle C, and it's 18. Side A is across from angle A, it's 27. Side B is across from angle B, which is 21. So I'm filling in these numbers very carefully here. And what I'm going to do now is solve this for angle C. So the first thing I want to do is get rid of the 27 squared and the 21 squared from both sides, which means I will end up having the 18 squared minus 27 squared minus the 21 squared. So what I'm writing in there in red, you can just do on this next line like I have, or you can calculate it the way you've got it. And I'm going to do my 2 times 27 times 21. I get negative 1,134 times the cosine of angle C. And then 18 squared minus 27 squared minus 21 squared is negative 846. And if you ever come across a video and I've made a mistake in my calculations because I've hastily done them, please zap me an email, let me know, and I will let others know and try and do a fix on my work here. All right, so negative 846 divided by 1,134 negative, that gave me approximately 0.7460. And that's the cosine of angle C. I'm going to undo the cos by second functioning the cosine on that 0.7460. I've got all those digits on my calculator, and I get angle C approximately equal to 42 degrees. All right, all that work just to get this little sweet little angle right here. Now I can work at getting the height of the triangle. Notice triangle ADC is a right angle. Okay, triangle ADC is a right angle. So I've got my SOHCAHTOA that I can use. In that triangle, I know the hypotenuse, and I'm trying to find the side that's opposite to my 42 degrees. So opposite and hypotenuse works with the sine. So the sine of angle C will equal my opposite over my hypotenuse, which is 21. So my 42 degrees, I still have my answer on the calculator with all the digits there. So I'm just actually going to use that. Opposite over 21. So I'm going to hit the sine button, and then to get opposite by itself, I'm going to multiply both sides by 21. Oops, now that looks like 211. There we go. So times that answer by 21, and I get about 13.98, or almost 14 on that. So my opposite side, or side AD, is equal to 13.98 meters. So now I can find my area. My area is base times height divided by 2. My base is 27. My height is the 13.98, or 14 almost, and divide that by 2. So again, I've got all those digits on my calculator. I'm just going to use them. And I get approximately 188.8 square meters. So he only needs one bag, and he actually can use the bag twice, because he could use it for one coat, and then 3 months down the line, or whenever it is he needs to refertilize, he'll still have enough to do a second fertilization of that lawn. So hopefully that makes sense, and hopefully you won't have too much trouble with this. And don't forget to put a final statement on your word problems.